What's poppin', dogs? Mr. Allen here with some graphing of piecewise functions, and we got a doozy here. I got a radical, absolute value, and linear equation as a part of this piecewise function. So here's how I like to go about graphing piecewise functions. Whatever those domain restrictions are, I generally plug those points in and use those as one of my points to plot, okay? And then I'll pick either some other critical points of that function that I know about, or I might just pick some values to the left or to the right, depending on what my domain restrictions are. So let's start with plugging -3 into this radical right here. And if I do that, I'm going to have the square root of -3 plus 1. That's going to be 3 plus 1 is the square root of 4, which is just 2. So I have the ordered pair, -3, comma 2. Easy to plot, right? -3, 1, 2, 3, positive 2, up 2. Now, my x needs to be less than or equal to -3, right? So I could pick a point like, say, -4, plug it in. We could do that. If I do that, I'm going to get the square root of 5. Ugh. Right? I don't think I want that, right? Let's try to think of maybe a better point to plug in that'll be nice and see where it goes. Well, my next perfect square, because this ended up being 4, would be 9, okay? So perhaps what I really want to plug in here is -8. Because if I plug in -8 here, which is less than or equal to -3, then I'll get the square root of -9, which is a perfect square, or sorry, square root of +9, which is a perfect square, and is 3, okay? So let's do that. Let's plug in, and I'll show that work over here so we can see what the heck's happening. But if I plug in -8, which is a value that's less than or equal to -3, and I add 1 there, boom. This is going to be, that's an 8 there. This is -8, which is +8, plus 1, which is the square root of 9, which is 3. Okay? So you could pick some creative points pending the function that you're dealing with. Definitely the case when it comes to radical functions, right? And then that's really the main one there. So picking nice points because you're going to be square rooting them. Let's find some perfect squares. So I plugged in -8, and I got 3, right? So that's the point I'm going to plot. So we got 1, 2, 3, 4, 5, 6, 7, and 8. And then we got +3. So we're up 3. It looks like right about here. And we know it's a radical function, so it's going to be kind of going off at a slight curve like that. Cool. The other point would have been maybe somewhere around there, like the start point. Looks like it would have been +1 because that would have made 0. So it would have been somewhere over right about here is where that graph would have started and gone up, right? So we're only getting a portion of that radical function, okay? Everything that was less than or equal to -3. But the strategy that I used there was plug this guy in, evaluate it, that's my starting, pick a point to the left. We could have picked anything we want, but I picked -8, knowing that I would get 9 inside the square root, which is easy to square root. It's a perfect square. All right, let's move on to the next one. I'll go green with this one. So we got an absolute value function. Remember, those are the shape of like a V. Pending if we get the whole picture here, I'm not sure yet, okay? But I will pick these 2 points here. Let's plug them in, right? So if I plug those in, I'm going to do this without writing anything down. -3, the absolute value of -3 is +3. What's 2 times 3? It's 6. 6 minus 4 is 2. So I will get the ordered pair of -3, comma 2. And then if I plug in 1, 2 times 1, right, because the absolute value of 1 is just 1. 2 times 1 is 2. 2 minus 4 is -2. So I'm going to plot those 2 points. -3, and then we got +2. Oh, interesting. Interesting. An overlap. I'm just going to put a little open circle there, right? Because that one would have been open. This guy was closed because it was equal to. I forgot to specify that and stress that. Because x is less than or equal to -3, the pink one there was closed. This guy would have been open. If you're doing pencil, don't even worry about it. I often just do that for a teaching purpose, right? But you don't need to like make an open circle over that guy. But I am showing that because of this graph and I'm color coding things. All right, and then we've got 1, comma -2. So 1, -2, that is open as well because it's not equal to. Cool. Now let's figure out some other things going on here. What if I plugged in 0 for x, right? Because I have no left or right shift. So like if you think about like a vertex, kind of like with quadratics, it works the same. I'd have 0, comma -4. 0, -4. So now I have this V shape, straight lines. I wonder if I have a ruler over here. Ooh, I have one. Hold on. Hold on. This will be nice. This will be nice. Look out. Making it fancy. This is my old ruler from grade school. It says, James Allen, waza. That was big. That was big back in the day. We loved to do that. A lot of Z's. A lot of Z's there. If you can see that, I know it's backwards because this is the correct way of writing it. And then I flip it. It's a whole thing, guys, with the process here. But it makes the videos pop, right? Light up. Anywho, there we go. So that's the middle guy right there. And then let's get the last one. I'll do that one in orange. Orange, you glad we're almost done with this problem? All right, anyways. I'm going to plug in 1 here to this one. So if I plug in 1, I'm going to have 1 comma something. I'd get -3 plus 1. That's -2. So 1, I did not plan this, guys, to make it all overlap like that. But here we are. 1, -2 is a closed circle there. And then what am I going to do with this one? Well, I could pick a point to the right, or I could do what I know about linear functions. We're going to go down 1, 2, 3 over 1. Down 1, 2, 3 over 1. I don't even know if you can see that anymore. But in any event, we have ourselves a nice straight line with this piecewise function. Whoop, whoop, boom. There we go. I wonder if we can see that if my watch updates. It's not. All right. So hopefully we can see that. But that's it for that piecewise function there, guys. That's a fun looking function. And we can ask other questions about these things. Intervals of increasing, decreasing, evaluate at certain points, stuff like that. But that was cool. That's the fun little zigzaggy awesomeness. My orange marker is really dripping there. Anyways, all right. Hope you guys enjoyed the awesome piecewise functions. If so, maybe you'll like it, click the button, subscribe, share it out. Make sure you check out some other videos as well because we're having tons of fun with piecewise functions. See you guys later.